In this video, we're going to take a look at the linear discriminant analysis. The command for that is called LDA, but you would need the library MAS in order to get that function. So if you do not yet have MAS on your computer, be sure to download it at first. Let's take a look at the help section for LDA. And as you can see in those arguments, it actually looks quite similar than a standard linear model or a generalized linear model. You would just have to specify the dataset, which in our case is called empty cars, as you can see here. And then we have a standard formula argument, like you would also find in box plots or in the linear models or generalized linear models. In our case, the formula would be of this format. We have COL for cylinder, so that is actually what we want to model, and we are using weight and MPG as our explanatory variables, and we can just use the plus sign to combine those two variables in this formula. So we can now actually run this line over here. It is called LDA for linear discriminant analysis. We have the data and we have the formula, and I'm calling the whole object myLDA. So let's run this one, and also let's take a look at the output. Alright, so as you can see in the console, we now have various numbers which are actually the result of this call. The first thing we get are the prior probabilities of the groups. This is actually the proportion of a class in the dataset. So for example, in this case, we would have cylinder count 4 as our class, and there are about 34% observations which have class 4, 21% observation of class 6, and 43% observations in class 8. And if we take a look at the plot, you can indeed see that this class 6, so cylinder count 6, is the smallest group with only about 21.8% of all those observations. So this is actually what the prior probabilities of the groups are telling you. The next thing you get are the group means. And those are actually all the group means for each independent variable and each class. And we also get the coefficients, which are calculated to define the areas of each class. So this is this one over here. So now we have actually fitted our model and we called it myLDA. And the next thing we're going to do is we're going to specify a test dataset, and we're going to see with this test dataset how good this model actually works. I'm specifying a data frame with the exact same columns as the empty cars dataset. I'm specifying weight, MPG, and the class with the cylinder numbers. And I'm calling this whole data frame test. So in this test data frame, we have now 4 observations. We have cylinder count 4, cylinder count 6, cylinder count 4, and cylinder count 8. So those are our 4 observations, and we are now actually going to use this test data frame in the predict function. And I'm calling it myLDA.prediction. It's the function predict. We have the object myLDA. So this is our fitted model with this linear discriminant analysis function. And I'm also specifying new data, which is this test data frame over here. And I'm only using columns 1 and columns 2, so weight and miles per gallon. And the output should only give me the classes. So therefore I'm specifying $class. So if I'm now running this line and I'm taking a look at this myLDA.prediction, the computer actually tells me now what it has calculated. So in this case, I'm getting 4848. So this actually means that by using the myLDA model, the computer would predict that the first observation would be of class 4, the second observation of class 8, whereas in reality we specified class 6. The third observation is again 4 and again 8. So 3 out of 4 observations have been predicted correctly. We can also get a table to compare the prediction and the test data set. And as you can see on this table, the diagonal value, so it's 2 and 1, actually show the correct predictions, and we only have this one over here, so this is actually the wrong prediction, because in this case the computer predicted a class 8, which is shown over here, whereas in the dataset itself it was specified as a 6. So this is again the second observation which was not predicted correctly. And if we take a look at our XY plot, this data point is indeed in this questionable boundary area between classes 6 and classes 8, so it is hard to predict, and it could probably belong to both classes. Alright, so this was how linear discriminant analysis works by using the LDA function in R.